So last week, I think, this Tuesday, I stopped at Kanu Maps. So I will continue that tutorial session in next week. So today we are gonna learn about combinational logic circuits. So please pardon me with me my handwriting. So anyone heard about combinational logic circuits before? No? Okay. So in today's assignment also, I think you have did some arithmetic options, operations, addition, subtraction. You did these operations, right? So today we are going to learn about actually how to do this addition by using logic circuit, right? So it is very interesting topic. So there are two other concepts. So the first one is combination logic circuits. So other thing is sequential logic circuits. So I won't have any time to do this part. So I will give some brief introduction to combinational logic circuits. So here we will do not use memory. Here we are going to work with memory as where we are going to build the our registers, and from that you can going to improve this to build the RAM and other memory circuit as well. So they are also included to your course. So today we are going to speak about combination logic circuit. Is please come. So it won't use memory, and here in sequential logic circuit we are going to use memory as well. So another differentiation here is sequential logic circuits. The output will depend on here. Output will depends with the present input as well. The present input and let me check it's recording. Yeah. Present input and the previous output as well. Previous output as well in sequential logic circuit, and here output will only depend on the present input. Depend with the present inputs. Right? Those are the main differences. Combination logic circuit, we are not going to use memory, and in sequential, we are working with memory as well. So you will going to learn about how to create a memory inside in the sequential logic circuit. These are the main differences. And output will depends with present and please come. Present inputs and the previous outputs. Here, combinational logic circuits, the output will only depend with the present inputs. So these are the main differences. So as I mentioned early in combination logic circuit, today you are going to learn about how to do mathematical addition, not logical addition. So in logical addition, if you last Tuesday you learned about how to the logical addition. That means operator, right? Okay. There is two inputs in logical addition, that is O gate. So 0, 0, 1, 1, 1, 0, 1. So what will happen is 0, 1, 1, 1. So this is logical addition. So what is about mathematical addition? In mathematical addition, first for the initial part, what is the most easier addition? Is binary addition. Adding two binary values. One digit binary value. So what are the binary one digit binary values? Binary වලින් addition කරනකොට initially පළවෙනි step එක ගිහලා 1 bit binary addition එකක් ගන්නවා. We have to take 1 bit binary addition. So I'm asking what are those? Binary කියන්නේ දෙකයි. In decimals there are 10 numbers, right? What are those? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are the binary. 0 and 1. 0 and 1. Right? So what are the occurrences are there to add these numbers? මේ numbers දෙක add කරන්න පුළුවන් අවස්ථා ටිකක් තියෙනවා. Yeah. Right. Yeah. We are going to take only one bit. So what are the one bit? 0 and 1. So we need to add these numbers, and we need to find all the occurrences. How we are going to add these numbers, right? So what are the occurrences? How many occurrences are there? There are 4 occurrences, right? So what are those? 0 and 1. The first occurrence is adding 0 and 0, right? What is the answer? 0. Next one. 0 and 1. What is the answer? 1. Next one. Sorry. I am here two things. 1, 0 or 1, 1. Yeah, actually both are correct. 1, 0. It is also 1 and 1. So what is the answer here? Anyone? 1. So I am hearing another answer. What is that? 1, 0. 1, 0. So there is 2 bits, right? So is it correct? Yeah, this is correct. We are adding 1, 1. Then the first initial in let's say in decimal, you are adding 1, 1. So answer is 2. So but we need to convert into binary. So how we can convert 2 into binary? It will be 1, 0, right? This is the 2 to the power 0. This is 2 to the power 1, right? So so there are 2 inputs. This is A. This is B, right? 2 inputs. How many outputs are there? So let's start with inputs. A, B. So A 0, 0, 1, 1. 0, 0, 1. B 0, 1, 0, 1. So Here, what is the output? 0. Here, 1. Here, 1. Here, what is the output? 1, 0, right? So for the simplicity, not right, it's 1, 0. Right? So there should be 2 outputs, right? So what is the output going to be here? You need to think. Anyone? So I'm asking, are there any output in these 3 places? Output still on. Am I going too fast? No. Output still on. Zero. Why? You can see it. And I can pick up. Yeah, but you don't see if we add another 0 to these steps. So not going, yeah, please come. It's not going to harm to this output, right? So what that means, here we can say 0, 0, 0, 1, 0, 1, 1, 0. Right? No, right? Then what how many outputs are there? Sorry? Huh? 2 outputs, right? So let's say this is S1 and S2. So I think there is a name, correct name. Right. Actually, we can say this large, sorry, this large bit, we can say it is the sum, actual sum. Right. When you are adding, so like in decimal, you are adding 5 plus 6. Then what is the answer? 11, right? So that last the higher decimal is 1, which is going to carry forward to the next decimal point, right? Again, we got thought, all the prima das. What is das? 5 එකතු කරාම 11යි. එකක් ඉතුරුයි මේක we are going to carry forward to next decimal point. So then 31, right? So we need to do this here as well. So this will be the sum. This will be the sum, and this which we known as the report bit. So simply we can say this is carry. So right, guys. This is carry. This is sum. Right. So how many outputs are there? 2 outputs for our 2 inputs. So from this truth table, we can add 2 binary numbers, 2 1-bit binary numbers, right? Right. So this truth table is representing the half adder. So you need to write this down, right? Okay. So this is gonna be half adder. So half adder is only adding is for finding the sum, finding the sum of two bits. Right? Right. So it is half adder. So as I mentioned, there are two outputs. Right. Now I'm asking you to design the logic circuit for this truth table. You have questions, you can ask. Table master. Yeah. So I'm impressed with you. So most of you have designed the logic side. So I'm going to design it the gate. So how you can decide? So what is by looking this values, what is the gate you can identify? 0, 0, 0, 1. And gate, right? So this carry forward bit can represent by an AND gate, and this bit is XOR, right? So let's say this A V. So XOR. So output is sum. It is an okay, right? Anyone has problem? By using this circuit, you can add two binary or two bits. Those are 0, 0, and 1. So let's do here again. 0, 0. What is the output in the sum? In XOR gate? 0. Here, 0. 0, 1. Sum 1. Carry 0. 1, 0. Sum 1. Carry 0 and 1, 1. This one 0. This one will be 1. Right? Simple, right? So this is half adder. So now what we need to do? So we are know how to add 2 bits. So actually what is our goal? So our goal will be adding something like this. Say, 1. Right? Adding something like this. Then our problem is solved. So what is the answer here? 1, 0, 1, 1, 1, 0. Then here it is going to carry forward that way. Then what is the answer? 1, 0. No. It should be 1, 1. Right? It should be 1, 1, right? So we can do this part and this part. Can we do this one using half adder? Half adder එකෙන් මේ addition එක කරන්න පුළුවන්ද මෙන්න මේ ඊට පස්සේ addition පුළුවන් කියලා. So other subtraction. To do that part, you need to create full ladder. So I explain that part after inside the whole circuit, right? So first, there is a problem. Problem is adding 3 bits, right? You can identify that. You need to add now 3 bits, right? To do that part. So can we do that using half-bit? So how you can go decide? So this is about half adder, right? So here our inputs are A, B, right? So our problem was initially adding these one 0, 0, 0, 1, 1, 0, 1, 1. So only we can add them, right? But here in full adder, or not going full adder, but this particular problem, you need to add how many numbers? 3 bits, right? Can we add them using this one? Simply no, right? Why? So there are only 2 inputs. There are only 2 inputs, and we can only add these one 0, 0, 0, 1, 1, 0, 1, 1. There are no options. We are going to add this one, right? So what that means? Input to not one. Why? Right. So again, in half adder, that's why it's called half adder. We can only do the half of our problem. This is our problem to add binary values, right? So to add binary values, we can add these ones and simply add this one, like simply this one we need a half adder, this one also we need a half adder. For this one, we need not a half adder but something else, right? So we need to decide that something else. So in that something else, need to have 3 inputs, right? But we know this one. What is this one? This one is the carry forward bit of this half adder. Simply I say check this half adder, right? That is the carry forward bit. Carry bit of the previous half adder. Right? मैं मामा लिया ना मैं चलो So let's break this problem into sub problems. So what are those? Those are simply our primary inputs, right? So let's say again, this are AB, and what this is the previous carry forward bit. Let's say is carry in. Right. So now I am asking, by considering these options, so So there are 3 bits, right? So how many occurrences are there? Right? 8, right? There should be 8 occurrences. So A right? So then you need to decide how many outputs. So how many outputs are there here? Definitely there should be 2. Can anyone say there are 3 outputs? Please raise your hand if you are telling me there will be 3 outputs. 2 outputs? No? Only 1. Again, what තේරෙන්නේ නැද්ද මේක? තේරුණාද? main problem එක මෙන්න මේ වගේ digits දෙකක් එකතු කරනවා. The main problem is how to add binary digits like this, right? So simply I put the example adding 111 with 110, right? So before this I have explained add only 2 bits. So what are those? 0 1 1 0 1 1 0 0 0 1 1 0 1. So those are 2 bits. So in binary we are only dealing with 2 bits, 0 and 1. So how many occurrences are there to add those numbers? 4 occurrences. These are represented here and here as well. 0 0 0 1 1 0 1 1. When you are adding 0 0, the answer should be 0. 0 1 is 1. 1 0 1 1 1. For 1 1 we are getting. So in decimal adding 1 1 will be the answer is 2. And representing it in binary we need another bit 1 0. So there are 2 bits 1 0. So that means 2 outputs. So in these previous examples also we need 2 outputs then to clearly draw the truth table. So there will be no harm to insert zeros for these answers, right? Only this one will be 1. The 0 will be the last output will be 0, right? So this gate will be representing by using XOR gate, and this output can be representing using AND gate. So it is this, right? So this is the summation. So that means the last bit, and this will be the representing L4 bit, right? So I again I explain how we can add numbers by using this gate test, right? So this is half added, right? Only we can add these 2, 0 and 1, right? So from this gate we can do a small part of our problem. So our problem is this one, adding simply these bits. So when we do the binary addition, we identify that there is a particular case that we need to add 3 bits, right? We need to add 3 bits. So for that particular case, we need another logic circuit. So now we need to decide that one, right? So for that part, we identify there are 3 inputs. Right? So the first this input will be the carry forward with the previous output, right? So they say it is carrying, right? And the answer to add these three numbers, we get 1 1, right? We actually got 1 1. Are there any occurrences where we get something here or 1 or something in the front? Can be there such occurrences? Can be there? Huh? Yes. Yes, none. Example like here. Actually, no, right? Only 1 1 1 should be 1 C 1. It should be 1 1. We can write. We can add any zeros in the front, but are there going to be any ones? No, right? There are going to be only zeros. So it's relevant to put those, right? කියන්නේ එරුම නෑනේ වැඩ. So that means we are going to simplify the problem. Okay, so there should be 3 inputs and 2 outputs. So what is this? This is the current sound, right? So what this will be? It should be another carry bit, right? So let's say this is carrying. This we can simply say this is carry out. Please fill this truth table. So for the time, So what is the answer? We are going to add these 3. So what is the sum? 0, right? So there are not be any carry out. So this one 1 0. This one carry out will be 0. Sum will be 1, right? Right. For this one, B and carry. So that means adding 1. No. Yeah, adding 1 0 1. What is the answer? 1 0. So sum should be 0. This one will be, should be 1, right? So for this one, 0 1 1 0 1 0 1 1, right? Right. So now you need to design the logic circuit. So I will help you on this one. Right. So I will give you a meaning. So uh, right. So how we are going to get this carry in bit from the previous half adder, right? And there is another half adder for this part, right? So there is two half adders, right? So, okay. There is should be two parts. Right. So first we are going to add these ones. Then the summation is going to add with this carry, right? That's the logic. First we are going to add these ones, these two bits A, B, and then the summation of that is going to add with this carry, right? So what is the summation of AB? It is going to represent with here, right? From the XOR gate, right? So it is the no. So it's not the exact keyword. So this is the summation of AB. Sum A plus, right? So that summation is going to add with this one, right? So this should be our C in there. Did you understand that? But what we are going to do, first we are going to add this one, right? And the summation is going to add with the this C. So what is this? Then it should be, sorry, it should be, our sum, right? Right. So, and then there is two problems that are arising here also. The say C, say C1, and here also C. This is the carry out bit from these two, and this is the carry out bit from these two, right? 1 C. For C1, it's only AB. So these are 1 1. So others all will be 0. For C2, sum and CE. So what is the summation of AB 0 and C 0? 0, 0, 1 is also 0. And 0, 1 is 1, 1 and 0 is 1, then the C out is 0. For here it should be 1, right? Summation is 1, 0. Summation is 1, is 0. Summation is 1, 1, 1 and 1. Summation is 0. Here the summation is 0. And here this one also 0. So this one is 0, right? Did you identify? Here this C2, it is the summation of A plus B and CE. So in this case, summation is 0, right? 1, 1. The sum will be 0, right? Sum is 0 and 0 and 0. The answer should be 0, right? So for here as well, summation is 0, 0 plus 1. This is 1, right? So these are the answers we are going to get from C2. That means this one and from this one, right? By looking at these two outputs, you need to build this this output, right? Did you understand that? මේක තේරුණාද? ඒ කියන්නේ මේ circuit එක අපි දැන් decide කරන්නේ half adders එකක් වගේ. Now we are going to decide the that something by using two half adders, right? So there are intermediate outputs. Those are C1 and C2. So by looking this truth table, we have identified the answers or outputs that are going to get from these circuits. So those C1 and C2 are these, right? And we need to get this one, this carry out by using this C1 and C2, right? So that means 2 inputs and 1 output, right? Yeah. So I will decide here. We only need this carry out and C1 and C2. So C1, C2. So since this is only 2, right? There are number of occurrences. How many number of occurrences? 4, right? Those are 0, 0, 1, 1, 0, 1, 0, 1. And this would be our so for 0, 0. For 0, 0, what is the output? Here it is 0, here it is also 0, here it is also 0, and here it is also 0, right? So this is 0. For 0, 1. 0, 1 here. It is 1. 0, 1, 1. Right? So it is 1. 1, 0. Here it is 1, 0, right? Right? 1, 0, right? So what is the answer of 1, 0? It is 1. No 1, 0, right? For 1, 1. It's problem like this. Is this C1 and C2 is correct? That and you can find error. No? Yeah, I need to check that which books there should be some problem. Please recheck this. So C1 should be the carrying out of AB and C it plus summation of AB. Let's check AB 0, 0, 0, 0. One. The summation sum A plus B here is 0. Summation 0. Right, this should be 1, right? No, should be 0, right? Summation and this one, right? So 0, 0. Right, this should be 1, right? Yeah, this is 0, right? The final one should be 0 because summation of A plus B is 0, 0 and this one. So carry out is 0, right? So that's the error. Right? Yeah. Right. For 1, 0, we are getting 1. Here also 1, 0. Here also 1, 0. We are getting 1. 1, 0, 1, 0, 1, 0, 1, 0, 1. So also 1. And what is the output of this one? 1, 1. Like we can end the lecture here if you give me that this answer. You identify that's why I'm telling there should not be occurrences of 1, 1. Right? Again, 1, 1 in make උත්තරේ. ඒතර මෙතනට answer එකක් මොකක් හරි තියෙනවනේ මොකක්ද answer එක. මේ truth table එක තේරුණා නේද? මේ මට පොඩ්ඩක් පැටලුණා ඒක හතර කොට. පටල ගන්න බා මේ ලියා ගන්න. Because the intermediate output is this sum a plus b, right? So sum a plus b and this c and this c. So answer is this one. So output of this C2, the answer is this one, right? So we need to design this carry out bit by using this C1 and C2, right? So I designed another small truth table by using C1 and C2. So by with our knowledge, we know there could be 4 occurrences. So those are 0, 0, 0, 1, 1, 0, 1, 1. So by looking at this truth table, we identify for 0, 0, we are getting carry out as 0. For 0, 1, we are getting 1. So for 1, 0, we are getting 1. For 1, 1, we need to find 1, 1 from C1 and C2. There are no 1, 1, right? So what is the output then? No idea? So please raise your hand if you have no idea. Okay, I will explain this. Consider this is 1. So if it is 1, are there any changes to this truth table? Will there any changes? Make changes in the full one. Maybe answer. Full one. මොකද මේ 1 1 නැති හින්දානේ මේකේ එම ඇවිල්ලා තියෙන්නේ 1 1 නැහැනේ නේ මේකට 0 වුණොත් මේකට ආන්සර් එක වර්ධින්න පුළුවන් බෑනේ ඒකින්ද මෙතන 0 වුණොත් මොකද්ද මේ ගේට් එක XOR මෙතන 1 වුණොත් ගේට් එක මොකද okay right so that means so this is our circuit. You can either this add OR gate or both, not both, or XOR gate. So those two answers are correct because from this gate we are not going to have occurrences like these both are going to 1. මේ දෙකම 1 වෙන එකක් දෙන්න දෙයක් නැහැ. මේ truth table මේ circuit එක. ඒකයි මේ represent වෙලා තියෙන මෙන්න මේ truth table එක. ඒකින්ද මේකට answer එක 0 වුණත් අවුලක් නැහැ 1 වුණත් ප්‍රශ්නයක් නැහැ. ඒක we are going to neglect that one. Right? That is you need to identify. We are going to neglect that one. So it is not going to harm. So we can use either OR gate or AND gate to finish this circuit. So this will be our carry out. So this whole circuit is represent, or we can name it as the full adder. So only using this one, we can do this part, this addition 1 1 1. Then from next week, I will tell you how to actually add this now. So only you can add this one and these ones. Then you need to have some method or something something to connect these answers to get the final output, right? දැනට ඔයාලට පුළුවන් bit 3ක් එකතු කරන්න, bit 2ක් එකතු කරන්න. ඊළඟ සතියේ මම කියලා දෙන්නම් මේ විදියට සම්පූර්ණ ඉලක්කමක්ම කොහොමද එකතු කරන්නේ. Right? Yeah, we can wind up the session today. So thank you for coming. If you have any problems, you can now.